Here's a video for the constant force of interest, which is section 1.11. And first I want to remind you from last time, we know that 1 plus I is equal to 1 plus I m over m to the n. So that the im is just the annual rate compounded m times per year. So we're equating years here. And then if I solve for im, I get this expression. So what I want to think about is what happens to the interest rate as the number of compounds per year increases. In other words, what is the limit as m goes to infinity of im? So this is the limit as m goes to infinity of m times 1 plus I to the 1 over m minus 1. And just rearranging a little bit. So right now if you plug in infinity, I know we can't really plug in infinity, but think about plugging in infinity, you would get infinity times 1 over infinity is essentially 0. So you have a value to the 0, which is 1. 1 minus 1 is 0. So you really have infinity times 0. Now that's not an indeterminate form, but it's one that can be converted to an indeterminate form to be able to use L'Hopital's rule. So the classic technique is to rearrange it. So for L'Hopital's rule, we need a top and a bottom. So I'm going to move the m to the bottom as 1 divided by m. So on the top I have 1 plus I to the 1 over m minus 1, and on the bottom I have 1 over m. Now if I, quote, plug in infinity, then I have 0 over 0, which is an indeterminate form, so now I'm going to use L'Hopital's rule, and we get the limit as m goes to infinity. And L'Hopital's rule says take the derivative of the top and the bottom. So the derivative of 1 plus I raised to the 1 over m, that's a constant raised, is kind of like a 2 to the x, and the derivative of 2 to the x is ln of 2 times 2 to the x times the derivative of the x. So that's the rule I'm using here. So I get ln of 1 plus I times 1 plus I to the 1 over m times the derivative, I'm just going to write it that way, so the derivative of 1 over m. And on the bottom, I have the derivative of 1 over m. So those derivatives cancel. I shouldn't say cancel. Simplify to 1. And now when I take the limit, if I plug in infinity, the ln of 1 plus I is just a constant. It doesn't depend on m, so nothing happens to that. And the 1 plus I to the 1 over m goes to 1. So this is my limit. And that is called the force of interest. So in notation, that is delta, and this is your force of interest. It's your constant force of interest right now. And notice, to get the constant force of interest, we were using the accumulation function for compound interest. That'll kind of come up later. So the amount function for continuous compounding should look familiar in that it's e to the delta t. So if you think about what you've done in the past, this e to the rt formula, this r is your force of interest, or your continuous compounding interest. So that's kind of your amount function. This is your accumulation function.